Good morning. Does everybody have a great first day at Ignite? Exciting. I hope lots of really cool things yesterday. Some really awesome announcements. It's always amazing to be here. Being back in Orlando is always great. I'm actually from here. I live in Denver now, but I spent the last 13 years here, so feels very much at home. Very happy to be back. My name's Joey. I am a technical architect at the Microsoft Technology Center in Denver. We're an organization that's really dedicated to helping our customers. So I have a lot of events facilitating things like this, usually on a little bit smaller scale. I didn't expect, we had 1,000 people register for this. It was way, way bigger than I expected. Usually I bring in 20 to 30 people at a time back in my facility, but you're in a theater that's set up very much like some of our rooms. Every MTC in the world has a center kind of set up like this. So a big theater to come in, be able to do envisioning sessions, talk about where you could go. My background is specifically in software development, though. I managed software development teams for a number of years. I've been a software engineer for since I was a kid. I've been programming stuff. And today we're going to talk about something that I've been really passionate about, which is how to leverage DevOps tools with infrastructure as code. And so as I mentioned, I work out of the MTC. There's about 50 of us in the world. There's 16 within the US. Really, any major city that you would want to go to around the world, one of these facilities exists. You can talk to somebody like me that's here to help you, just kind of help you envision what you can do next, educate you on our tools and technologies, and then help execute through design sessions, POCs, things like that. So if there's any interest, you can certainly come find me or one of the other MTC folks. A bunch of us have these blue MTC jackets, so feel free to come up and say hi after. So I want to start with a level set. Has anyone here used some kind of infrastructure as code product before? All right, actually way more than I expected. That's awesome. What about a CI/CD tool, whether it's pipelines or anything else? What about infrastructure as code deployed with CI/CD? That's actually still a pretty good amount, but the number of hands keep getting less and less and less. But I think this has become something that's really, really critical towards moving fast in kind of a modern era. So I want to start talking about the basics. Whenever we talk about CI/CD, whenever we talk about infrastructure as code, any kind of modern developer practices, everything kind of funnels back down to DevOps. People hear the word DevOps, they think a lot of different things. You can talk to 20 different people and probably get 20 different definitions. For me, it's really a union of people, process, and products. So many people come in and they say, I want to talk about DevOps, and you want to talk about that last 10%. I want to talk about the tools. And we're going to focus mostly on the tools today, because I feel like most of this audience has a good idea of DevOps best practices. If you don't, see some of our great DevOps sessions. There's some really amazing stuff out there. Some great products, some great people talking about all kinds of different things today. But really, it's the union of all these things together. When we talk about DevOps, to me, it's not about automation. It's not about all these different things. It's about different groups of people coming together. So developers for years, kind of heads down, sat with their, just coded, built applications, tested them on their own, threw them over the wall, ops would go deploy them and maintain them. As we've slammed these groups together while moving to the cloud over the last few years, because it's gotten so much easier to build and deploy applications. It's got so much easier to manage infrastructure. We're starting to see these teams merge together. And a lot of the DevOps philosophies are around how do we get people together. And things like infrastructure as code, which we'll talk about in a little bit, really become a good way to make that more effective. We're starting to see more developers have a focus on how their apps live, how they run, how they're maintained. We're seeing a lot more ops people that are starting to program. If you're an ops guy and you're writing Ruby scripts or Python scripts or PowerShell scripts, you're programming whether you want to or not. And so how can we find some best practices and a tool set that helps enable us move really fast as we go forward? So I always like to start with why. This is a slide put together by some research by Gene Kim. He's got a whole bunch of books on DevOps. There's a really, really, really huge difference for companies that start to adopt these mentalities. So when we look at tools like infrastructure as code through Terraform or pipelines, companies that have really embraced this are doing things way, way faster, not 2-3 times as fast, 46 times faster deployment frequency. Some of that stuff is really pivotal. So for me, I get to work at Microsoft now, and one of the things that I get to do is kind of poke around some of our repos. So I have access to the Azure DevOps repo for Azure DevOps, which is in Azure DevOps, of course. I ran across a pipeline that had deployed 10,000 times. That product's only been around a few years. If you think about that scale, that's going hundreds of times a day. It's absolutely insane how fast things have started to move. And so 46 times faster deployment frequency, lower change failure rate, faster lead times for changes, faster mean time to recovery. We're not only deploying faster, but as we deploy, we're actually deploying better code. The stuff that's making it out into production is less broken. And it's not that people are making any less mistakes. If anything, we're making probably more mistakes, but we're catching them early. That shift left mentality, being able to take all these tools and technologies and say, how do we build out a pipeline? How do we build out something robust where we're not going to have to worry about something being broken? Because it's going to get caught early. It's going to move fast. So these are kind of the whys. And this really leads into what are the tool sets that help us have these faster cycles? Because certainly I can't deploy 46 times faster by clicking buttons 46 times faster. I can't keep that same process. I can't keep that same tool set. So we start to look at things like infrastructure as code. And this is pivotal to me. When we talk about dev and ops coming together, it's kind of the agreement of how our application is going to run. Even containers starts to answer some of that conversation too. But underlying, there's always something that's going to be running your application. And to me, even infrastructure as code, the word infrastructure has gotten a kind of weird rap recently where it's only VMs and storage. And so to me, infrastructure as code has become almost kind of the wrong name for what we're talking about. It's almost environments as code, because we're talking about provisioning literally anything that you would want your application to run, or anything that you need to run your application. So it might be raw infrastructure. We might be talking about virtual networks and virtual machines and all kinds of the baseline storage, but we might also be talking about functions. So I can provision a function app with infrastructure as code. Is a function infrastructure? It's underlying somewhere. But infrastructure as code lets us do a few different things, mainly define in a declarative way what our infrastructure looks like, what the desired state looks like. Actually, can I pause for a second? How do I start the timer? Somebody could come do that. That would be good. Just realize it's not running, and I know I'll ramble. I don't want to keep you all for hours. So, but can we define in a declarative way what we want our environment to look like so that every single time when I go to deploy it, it's always going to look the same. It's always going to be the same. And then can I provision in a consistent manner based on those environment files? So can I write out saying I need a resource group, and I need an app service plan, and I need some app services in a very human-friendly way, in a way as a developer I can understand it, in a way as an ops person I can go ahead and read it. But can I use a set of tools to help deploy those things for me? And then once it's deployed, can I manage some of that configuration as well? So one of the things that we'll talk about with Terraform specifically, but a lot of infrastructure as code tools, is not just being able to stand the infrastructure up, but be able to apply things to it, to be able to communicate with it, to get it to its in a state where I'm ready to put my application right on top of it. Oh, went a little bit far. So why? Standing up environments in the fastest means possible. That's what people think of a lot. And that can mean a lot of different things. So just time to deploy. A lot of infrastructure as code tools will do things like figure out your dependency graphs. So I've got 400 resources that need to come up together to be part of this environment. What do I actually do to get there? What order do I stand things up on? What's dependent on what? But it also means taking away the time that I sat at my machine doing deployments. So if I'm doing bad practices and I'm right-clicking to publish, things like that, or I'm manually provisioning environments, that can take a really long time. For me, my last company, it used to take about 3 weeks to stand up a new environment for a new customer. That's crazy to me, to spend all those dev cycles of people really just clicking around in the Azure portal, things like that. It took forever to get everything set up. When we finally moved to infrastructure as code, I got that down to about 30 minutes to deploy an entire new, fully configured environment for our customers. And that only took maybe 2 or 3 weeks to set up. It didn't take any longer to set up than it did to actually go provision the whole thing from start. I've actually gotten so performant with Terraform that I don't even go into the Azure portal for a lot of stuff anymore. I just write my Terraform scripts and go. So optimizing your operations, huge thing. Removing the human element. People make mistakes. Anything that a person does is prone to failure. So many times I've misconfigured stuff. I forgot to set storage correctly. I forgot to put database connection strings in. Has anybody run into that before? Where you go to deploy and suddenly it's broken and you don't know why because it's the same code, different environment. Removing people out of it. And then improved environment visibility and developer efficiency. Like I said, I'm much faster at scaffolding things out in Terraform than I am going around clicking in the Azure portal. For me, if I need to go create something that's similar to what I already have, I don't have to go do all that again. All I have to go do is copy paste my template, make some changes, reuse modules, all kinds of things like that to get much, much faster productivity. So if I've got a really robust deployment with dozens of resources and I want to deploy that to 5 or 6 environments, now I don't have to take 5 or 6 the amount of time to do that. And then store your infrastructure definitions right alongside your application code. This is what excites me because, and sometimes it scares the ops folks in the room a little bit, but we can take the patterns and practices that we've applied to software development for the last 30 years, like source control, pull requests, code review, all those kinds of things, and apply them to our infrastructure. So I can take that infrastructure as code, I can check it in, and I can be part of a compliance pipeline. I can follow all the patterns and practices that I've wanted to for a long time, and I've done successfully with software development, because I think most people are to the point now where they're deploying their applications through CI/CD, but deploying their infrastructure starts to become a little bit more rare. And so that's something that's really, really cool to me. So Terraform. There's a lot of infrastructure as code tools out there. Microsoft even has some of our own. But I've never used a product that was so easy to get started with. If you're not familiar with Terraform, let me ask, who here's used Terraform before? All right, so most of the audience is familiar with it. That's awesome. It is a tool for doing infrastructure as code, and I can do everything that I talked about. So writing declarative configuration files, defining what my environment is. It's able to be parameterized, so I can pass in variables to say, I've got one template. I don't need a dev template and a staging template. I have my infrastructure template. The same way that we build once and deploy that multiple places, I write my infrastructure once and I deploy the same templates multiple places with different configuration. So I might change VM sizes. I might change node counts. I might change where things point. I might turn some things on or off because I don't want certain features available in different environments. But it can do all that for me. And then plan and predict changes. It's very good about interrogating your existing environment to say what's there and figuring out what the diff is. So it's not just like writing a script using the Azure CLI to go provision things. It's idempotent. So it looks, and you can deploy the same Terraform script over and over and over again. And if it doesn't have anything to do, in 4 or 5 seconds, it's going to do nothing. Because it's going to see that your environment matches. Or if somebody changes something and you want to put it back, it'll put it back. And so it can handle all of these things for you, standing up your infrastructure. And then it creates something that's very, very reproducible. So I can take this and I can stamp it down over and over again. It's just text files. It's just code. So I can share this with people. I can build modules to say, here's how I go deploy X for my company. I want to publish that to a registry and be able to share that across my entire company. So everybody deploys the same thing the same way. And so I can bring my 0 to a fully working application time way, 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 way down. Terraform itself is an open source product. The whole thing's written in Go. It's on GitHub. You can go build it down, compile it yourself, use it yourself, install the binaries. It's extremely well maintained, specifically for Azure. So Terraform does work well with Azure. It also works with like 100 different providers. So you can use it to configure all kinds of different things. Of course, the major clouds. Microsoft and Terraform have, or Microsoft and HashiCorp, who's the company that makes Terraform, have a particularly close relationship, and that we actually have some contracts there where we pay them to maintain the Terraform provider for Azure. And so things are relatively up to date as we come out. Usually preview features are a little bit behind, but as things roll out into GA, they're almost always available in Terraform right away. And if not, we collaborate on GitHub. You can go in, you can contribute yourself if you want. I've made changes myself, or go on and say, hey, this is really important to me. Here's my use case. Can you go do it? And then there's this guy, Tom, that'll probably go do it. Tom's great. So Terraform open source is a really fantastic product, but that's not all that's available. Sometimes I need to work in the manner that I've been working for a long time, where I want to embrace infrastructure as code, I want to store it, but it might not be part of my entire pipeline yet. Or I might want advanced rules around governance. So I'm deploying to Azure, I'm deploying on behalf of a user or a service principal or something that has rights, but I might want to get even more granular than some of those things. I might want a generic user principal, service principal that a lot of people are using, but then apply specific governance rules depending on my environment. I want a nice way to be able to view my state files. So one of the things Terraform does is it keeps an idea of what it's touching, of what it's created, and it's not going to go mess with things that it didn't create. So if I have a resource group with 4 resources that Terraform put in there, if I go add a 5th thing, it's just going to ignore it because it doesn't want to go delete or change anything that you've put in there separately. And so it works very well with people doing things manually and people doing things automated together. So Terraform Cloud is a service. So there's a hosted service, Terraform Cloud. There's also Terraform Enterprise, which is self-hosted, that will actually handle your deployments for you, let you view your state files, handle role-based access control around doing deployments, and actually go ahead and write really, really detailed policies around who can build what, and even getting into things like cost prediction. So at HashiConf, maybe a month or 2 ago, they announced cost predictions coming. So as I go to roll out a change for my infrastructure, I might not know what all this is going to deploy until the script runs. I'll have a good idea. I can look at the plan, and we'll see what generating a plan is like a little bit later. But I look at that plan, and this might be really expensive. I don't know. So how can I get through that? How can I have a good way to view all that? So this is a little bit of what Terraform Cloud looks like. But these all work really, really well together. So I'd love to show you a little bit about what Terraform is. Just in case you haven't seen it, we'll just spend a minute or 2 here. So for me, I always write my templates in VS Code. I'm a huge VS Code fan. It's my favorite editor. I was a Sublime guy for a long time, but this is just the best for me. Can everybody see this okay? I know that it's a little bit small. I wish we had a bigger screen here, but this is what a Terraform template looks like. It's in a language called HCL, so the HashiCorp configuration language. It's JSON-ish. It's like if JSON was better, I like to think. It's not YAML, which is good. If you're a modern developer, you're probably neck deep in YAML for a long time. So basically, it defines all the resources that we're going to have. Anything that we would want within Azure or literally anything else can be defined in here, and it's going to go stand it up for me. And so starting up at the top, it's just going to say, where am I going to keep my backend? When I mentioned Terraform keeps the state file, there's a number of different options. I can keep it in an Azure storage account. I can keep it in Terraform Cloud, which is free, by the way, to keep your state up there. It works really seamlessly. I can keep it anywhere that I would want, or for this sake of the demo, I'm actually going to comment this out because I'm just going to keep it on disk. And I mentioned that because I want to keep it on disk. For me now, I would never want to do that when I'm collaborating with multiple people, and I would never want to do that in a pipeline, because Terraform needs to know what it can change. It needs to know what it can configure. It needs to know what it can touch. That state file needs to be accessible from everybody running Terraform against that environment. So in CI/CD, you have to have some kind of remote backend. Otherwise, every time you go to deploy, it's going to see resources that are already there and be confused because it's got duplicates, and the whole thing's going to kind of just stop and say, I don't want to overwrite this for you. You need to tell me what my state is. So I can also define the provider. If I don't, it'll assume what it is, but I like to hard code this in here because it's to a specific version. The Azure RM provider is paired with the Azure APIs, so the Azure Resource Manager APIs. Terraform works against the Azure Resource Manager APIs to go provision your resources, so that's well versioned, and so the provider version is tied. So if there's a specific version of a resource that changes over time, just keeping the default provider without changing it, you may eventually drift into some inconsistencies. And then I define what I want to build. So in this case, this is really simple, and this is something that I love about Terraform, is you can read this. If you've ever looked at an ARM template, it's a little difficult. So here I'm defining an Azure RM resource group. And in this case, I've called it default. Default's kind of like the variable name. It's really the resource name used within the template. It's not used anywhere else. And then I give it some parameters. And here I'm going to say name and location, because that's all a resource group really needs. What region am I going to deploy it in, and what is its name? And in this case, this is where I was talking about parameters in Terraform make a lot of sense, or can be really powerful. I have really strict naming conventions that I use myself, because I like everything to be nice and pretty. I always like to find them. I hate opening up an Azure subscription and it just being a mess everywhere. So I follow our old naming conventions doc. If you look at the Cloud Adoption Framework, we actually changed them in the last 2 weeks, which is a little bit frustrating, but so I like to say, what is my prefix for my resource group? What's the name for the resource group? What environment is it in? And end with -rg, so I can tell it's a resource group if I'm just looking at a list. And so these are variables that I'm going to pass in. And so my resource group is going to say something like Ignite 2019 demo staging RG. If I were to go deploy this for production, it'll say Ignite 2019 demo production RG, because I'll have different variables passed in when I run it on each. The location can change. And here I'm creating an app service plan. So in this case, it's our platform as a service offering, just to host a website. So I'm keeping a really simple .NET app. I've got just an ASP.NET Core app here, just .NET new MVC and dump it out. And so I'm creating my plan. It's on a standard S1. It's Linux, so .NET Core running on Linux, which is actually going to put it inside of a container for me. I can manually specify containers if I want. And that's actually what I'm going to do with the initial deployment. So I'm going to start this out with this Nginx Hello's demo. So when Terraform lays this down, it's going to apply some configuration to say, I want to stand up this container. And this is pulling from Docker Hub. It's just an Nginx real quick page that gives you your IP address back. But that's not what I want long term. I want my app on there. And so some of the things that we're going to walk through is how do I get my app on there after I go provision my resources in a nice automated fashion. And that's one of the other things that I can see here, output app name. Sometimes I need to use pieces of my Terraform template later down in my pipeline. So when I go to deploy my application, I might not know what it's called. If you've ever tried to provision like a storage account, the naming conventions on them are really strict. And so people use hashing algorithms to figure out something that's small. For something like this, I've seen people, because some of the resources in Azure are named based on DNS, they have to be globally unique. And so you can't pick something that's easy. And so sometimes people will put 4 or 5 random characters in there. Every time it's provisioned, it's going to drop a random name in. To use that later in my pipeline, I need to know what name it was. And so one of the things Terraform can do is right from the Terraform CLI, I can do Terraform output and then ask for output. And if you look, this is referencing the Azure RM app service named default, and I'm grabbing the name. And so this doesn't exist until it's deployed. Some of the other things I might even see is like, I'm deploying a database, and that database is going to have a random username and password I'm going to generate for the admin. Random username and password, I don't know what that is. I don't want to keep it myself. I don't want to record it in my logs. So I might use it as output and dump it in Key Vault or HashiCorp Vault, things like that. Which actually, there's a whole session on Vault and pipelines tomorrow, same time, same place. So this is what a Terraform template looks like. If I flip over to my terminal, which, by the way, the new Windows terminal is awesome, I run Terraform init. Oh, I didn't save this. So this is saying, where's your backend? In this case, I wanted to comment this out. I come in, I run Terraform init. This is going to reach out. It's going to pull down the newest version of the provider. It's going to say it's good to go. And then I run Terraform plan. This is going to reach out and interrogate my environment, see what's there, tell me if there's any problems, and tell me what it's going to provision. So this is going to say, hey, here's all the resources that you might need. Here's what I want to go create for you, because this is what's missing. It's really good at doing differentials, too. So if I'm on an app service and I change from an S1 to a P1, it's going to know that's a change. If I change the app service name, it's going to know, hey, that's a DNS update. I actually need to go provision a new resource. So the plan's going to tell me what I need to do. The plan is really, really critical, because if I change my database name, it's going to go drop and recreate my database. So you want to make sure to audit these as part of your deployment process. And so I can see everything that it's going to go deploy. So this is the full rollout of all the settings that are available for my app service. So real quick, that's Terraform. Terraform with Azure Pipelines is where I think it really, really starts to shine. So as I deploy my application, I've got a continuous integration, continuous deployment tool. I want to deploy my infrastructure with my apps. So Azure Pipelines, if you're not familiar with it, is Microsoft's CI/CD tool, or one of Microsoft's CI/CD tools, because we like to have multiples of lots of things. GitHub Actions is very similar, actually underlying. It's based on some of the same code and a lot of the same team. So it's pretty extensible either way. You can use either one pretty flexibly, but we're going to focus on Azure Pipelines right now. And it's really to build any language on any platform and deploy to any cloud. It is an orchestration tool for your builds. It will run on Windows, Mac, Linux agents, anything that you would want, any script that you would want to write for your builds. It can go deploy, build, manage, test, release your applications. It's also really extensible. There is an entire marketplace of extensions, hundreds, thousands of extensions. A lot of community members have written to make some of this stuff easier. Some of what we're going to talk about today is one of those extensions that's coming, and I'll show it a little bit later. There's been a lot of support for Terraform, but we're starting to get some official support for Terraform and pipelines. And then it also has native integration with Azure Container Registry, being able to provision a Kubernetes environment, know the environments it's deploying to, all kinds of things like that. Azure Pipelines also has two different ways that you can interact with it. For a long time, when it was Visual Studio Online, Visual Studio Team Services, we had a GUI. The GUI can do all kinds of stuff, anything that I would want through tasks, things from the marketplace, things that are built in. In this case, I'm installing Helm, which is a package manager for Kubernetes in general. I'm using it against AKS. I'm adding an Azure Container Registry repo, and I'm calling Helm upgrade against an AKS cluster. It's all through the GUI, works really nicely. I see a lot of people take this as the first step, but I'm a developer. If I'm keeping my infrastructure as code in my repo, I want to keep my build steps along with that same code in the repo. So I have every commit is an entire slice of how to build, test, maintain, deploy, provision, my entire application stack, everything all together. And so I like to use YAML. I don't like to use YAML, but I like the YAML pipelines. YAML's fickle. You'll use a good editor. VS Code has some great plugins. It's very space sensitive, and so just making sure you have things spaced out properly. You can be really effective in it. It's just a little bit of a learning curve of how to get things indented properly. But I can define everything as code here. So all the tasks that I would want to use, I can use. So in here, I have the Azure CLI task, and so I'm running some Azure CLI stuff. I can also just write a script. And so if I just want a script on Windows or Mac, it's going to be in CMD or on Bash. If it's on Linux, if it's on Bash. If it's Windows or Linux, I can choose PowerShell if I want. Whatever I would want to do to deploy my app, I can code out in here. And so I want to show you real quick what that looks like. So flipping over here, this is Azure Pipelines. This is what my application looks like, and this is actually a classic editor. And some of the things that I want to do is to say, with Azure Pipelines, how do I use Terraform inside of it? There's a lot of different options, but for a long time, it was a little bit complex. Before I get right into that, let me flip open my app pipeline. So this is the classic editor. I can also go right in line and say, I've got YAML. In this case, this is running Azure Pipelines or Azure DevOps. It does have Azure Repos. Azure Repos is a source control tool, but we also have GitHub. I keep all my source code in GitHub. And by the way, this is all in GitHub. I will share the link to the PowerPoint later. I'll make sure to upload it, and I'll have links to all the repos and all the demos that are in here. But I can actually edit my GitHub repo right from Azure Pipelines. And it gives me this nice editor for tasks to be able to say any pre-built tasks I can put in here. And so some of the things that I'm doing, in this case, I'm building my .NET application. Well, I have it built in an earlier step here. But I just want to run .NET Publish. So really simple. I know the commands for that. I'm just going to go write it. But there's some other things like deploying to an app service. I don't want to zip it up and do an AZ zip deploy and script all that out manually. There's a nice task that just says, go deploy for me. And so I set up a release stage in here. And you can do multi-stages that run on multiple environments with multiple jobs. You can really orchestrate a complex pipeline. We're actually, when I mentioned that pipeline that deploys part of Azure DevOps, that's deploying to like 40 or 50 environments. It's this massive, massive thing that you could never do by hand. And so right from here, I've got a task for saying, hey, I want to deploy an Azure web app. And some of the things you'll notice is there's no keys here. So this is where I think extensions really start to shine within Azure DevOps, is that I can manage connections to services and share them with my pipeline. So I have access to an Azure subscription. I have access to Azure DevOps. I can go create a service connection that says, hey, Azure DevOps, I want to talk to Azure. I hit authorize. It creates a service principal in the background, stores all the keys. I don't ever see it. And I can share that with either other people or authorize it to individual pipelines. And so I can bless this pipeline to say, you can deploy to my sandbox environment. I might be able to bless another pipeline to say, hey, this has been thoroughly reviewed. This can go to my production environment. And so as an IT person, as a security administrator, I can walk through and have a very, very strict compliance process around what I want a pipeline to look like, and then give it that thumbs up to say, yeah, as developers, you don't actually have access to production, but you're going to define what your infrastructure in production looks like. You're going to go through all the compliance steps. You're going to go through all the security scanning, everything that you would want, and your pipeline is going to have access to get out to production. And so I can smoothly go CI/CD all the way out to production every day, totally hands-off as a developer, but still meet all those compliance requirements that a lot of us are subject to. And so this is what YAML looks like. In this case, I've got a couple different stages. I'm reusing basically the same task to do dev, staging, and production. If I go to the Azure portal, I've got web apps for all these, just deploying an application. I can do the same thing with Terraform. The Terraform CLI is actually installed on Azure DevOps Linux agents by default. So we have a really close relationship. Actually, if you're using Terraform, you don't have to install it on your local machine. Anyone here familiar with the Azure Cloud Shell? So if you pop up the Azure portal and you click Cloud Shell in the corner, just a little cursor icon, it'll drop you right into an environment where you get access to the Azure command line. You also get access to Terraform. I can actually write all my scripts right in there. But Azure Pipelines and Terraform go really, really well together. Being able to provision my infrastructure and then deploy my application to it, for me, for teams that I've led, for people that I've worked with, is a game changer, because I can go with a new project from 0 to fully working deployed application in a new environment in seconds, which is really amazing. And so one of the things we wanted to do is make this easier. There's been tons of community adoption. There's been tons of people that have gone out and said, can I take that concept of service connections and let Terraform use it? Or can I take service connections and talk to Terraform Enterprise, because I want to do my deployments from there, and still use those kind of things to kind of highlight my extra level of governance and RBAC and best practices, because that's how my IT folks are working. Or even as a developer, I want to do CI/CD with infrastructure as code, but my infrastructure people aren't on board with me doing all the deployments from Azure DevOps. They're going to go use Terraform Enterprise or Terraform Cloud, manage everything there themselves, but can I just give that a nudge every time I need it to roll out infrastructure? So as part of my pipeline, can I just reach over and say, please deploy for me? So I don't actually control the deployment. I may stick in my business model, because that's hard to change, but I can control when those deployments go out so that they're in sync with my applications and have it totally be hands-off. And so today, we've got something cool to talk about. We're announcing Terraform for Azure Pipelines. So we're releasing an official extension in the marketplace with full support for Terraform, Terraform Cloud, Terraform Enterprise. And it's in preview right now. It would be out, but the guy that is working on it with me is in Ecuador. So as soon as he's back, it'll be out, published in the marketplace. But a HashiCorp-owned official extension for Terraform for Azure Pipelines to be able to use this seamlessly in any way that you would want. So as I said, it's got support for Terraform open source, Terraform Cloud, Terraform Enterprise. It also has a Terraform installer. So the default version that runs on the agents is relatively new, but it's not necessarily always the newest. You might want to use something older, so you can also control what version. It wraps everything really nicely. The goal is to make this as easy as possible. Can I access service connections to not just Azure, but Azure, AWS, GCP, wherever you would want to deploy, so that I can use all the best patterns and practices that we've used within Azure DevOps for years, or that suite of products for years, because we change brands a lot, to then give access to that to Terraform and let Terraform go deploy. So as a developer, I can deploy to dev, staging, and production, but I might only have access to dev. My pipeline has access to staging and production. And so can we do this in a really easy way? And so I'd love to show you what that looks like. So there's a number of different options. I had this one template up here before. Let me pull it up again. But using the classic editor, if I just want to use tasks to manage my deployment, totally fine. I can go through here and say, I want to install Terraform because I want to use a specific version of it. I want to do a Terraform init, which is going to pull down a provider. I want to run a Terraform plan, which is going to tell me what it needs to change. And then I want to run Terraform apply. Terraform apply is going to let me take that plan and then apply it against my infrastructure. And so that's one of the great things to mention with Terraform plan. It'll show you what the diff is, but you can also output it to an actual file. One of the things that I like to see a lot, if you're using manual approvals between stages within a release, I mentioned that plan file. If I were to change something like a database name or something that's a DNS entry, it's going to go recreate that resource. That's a little bit risky. I think it's less risky having a well-formed way to review it and having a good process getting it in than somebody just going and manually doing it. But sometimes you want some eyes on that. And so part of what I can do with my pipelines is to say, I want approvers between pipelines. And so I may actually have one stage that builds out a plan file, and then the next stage executes that plan file with a manual approval step in the middle. So somebody has to give the thumbs up or thumbs down just to say, yeah, this is good, it's safe, this is what I want to deploy. You're not standing up 10,000 VMs. Ideally, you're using something like Terraform Enterprise, and you've got policies in place to help enforce all that, or you've got policies within your Azure subscription to limit what you can do. But I might want to be able to have a more robust approval process around that. And so I can split that up. But this is what it looks like from the classic editor. This has been something similar to what's, there's been a bunch of extensions out there that do this for a while. The one thing that it hasn't had is Terraform Enterprise support. So right from Terraform Enterprise, I can actually pick a service connection out to Terraform Cloud. I don't have one set up right now, but I can go ahead and click this one, and then pick a number of different commands. So not only can I use Terraform Enterprise to go deploy my app, but I can actually control my Terraform Enterprise workspace as well. And so if I'm using something like Terraform Cloud or Enterprise, I can actually go automate some of my workspace management tasks, like creating a new one, provisioning applications in it, and then sending a request out to somebody to say, hey, can you go review this? And so I can have all of this together in here. Well, I can also put all my app deployment in here. And so I want to flip over and show you what this looks like, not so much in my classic editor, but what does this look like in YAML? So what does this look like as a multi-stage deployment? How can we actually see something quite robust? And so what it used to look like to use Terraform in Azure was a lot. I would have to run my init commands. I'd have to manage a lot of keys. This is kind of what we would do in the past before today, saying I need to be able to have references to all these different things. When I run my plan, I've got to message, or I've got to manage my client ID and secret, how it's going to talk to Azure, how it might talk to AWS, how it might talk to GCP. And then every time I want to do a release, I've kind of got the same thing over and over again. I want to make this as easy as possible. From an ideal developer standpoint, I want to be able to just drop in and say, I just want to have my plan and execute my plan. And then maybe I want to use that as part of some other steps in my pipeline. And so I'd like to walk through what I see as a best practice for using Terraform within Azure. So this is an Azure Pipelines YAML file. You can probably make some assumptions about what it's doing at the beginning. So I've got a number of triggers because I want this to be continuous. So as I push out my code, as I push out my infrastructure, it's just going to roll it out. I've been using this for quite a long time, and I just write Terraform files and I push them out, and they just automatically deploy. I don't have to worry about making changes. They're going through my well-tested, robust pipeline out to dev, staging, and production. And so I can define what those stages look like. And I might say, hey, I need to build my application. I've got some .NET stuff that needs to run. I'm going to go do that first. I want to build everything up. I want to package an artifact that is my set of binaries. So in this case, I just want to have a bunch of DLLs. And if you look here, I'm using templates. So if you're using Azure Pipelines a lot and you're using YAML deployments a lot, get used to using templates. They make it way, way, way easier to see because you don't have this long script. And it makes them really reusable. One of the other big things that's beneficial about YAML is that all those steps to release my environment, all those steps to create my application, all those steps to create my environment, those are the same no matter where I go. or they really should be the same, because Terraform is going to handle the difference in environment by changing configuration, because I defined all those variables. And so here I've got a staging stage that reaches out to my release template for staging. In this case, I've got a build template for build, and I'm passing some parameters in. So I'm saying, what's the environment, what's the Azure subscription, and then where am I keeping that Terraform state? In this case, I'm just dropping it in a storage account. Ideal case, I'm using something like Terraform Cloud that'll help manage it for me and give me a much, much better user experience around that. But right now, I'm using the same thing to go staging in production. In this case, staging here and production here are defined from the GUI, because I might want to have this template be reusable across multiple teams. But because I'm just giving it the name of the subscription that I'm going to, that means I already have service connections created within Azure DevOps. So I don't have to worry as a developer about committing this. This can go in my repo. It's just some text. It's perfectly fine. No keys in the repo, no credentials, nothing like that. Terraform actually helps you get away from keys in your repo quite a bit, because some of the things like generating database passwords, generating strings that are used as secrets somewhere, I can generate them, keep them in my state, apply them as configuration in my environment. I never even have to touch them as a person. So even as an IT administrator, if I'm using something like Terraform, I will never even be in possession of the secrets, because really, you shouldn't. I just need to know that this can talk to this, and that's it. So let me show you what these look like. The build template is quite straightforward, very similar to what we saw before. In this case, I'm just running .NET Publish. This set-e-x, by the way, if you're using Terraform, or sorry, if you're using Azure Pipelines, or really any kind of YAML build steps, this is great to throw in if it's Bash, because this will make sure that it says, I actually output what commands I'm running, so the logs aren't kind of blind. And then if any of those commands fail, Bash by default, if I've got 4 or 5 commands in a row, and I run the whole thing as a script, if those first 4 commands fail and that last one succeeds, Linux considers it a success. And that's not really what we want in our deployment pipeline. If something fails, I want the whole thing to fail. So that's a great flag to throw on. But I'm just going to build my DLLs and then dump it in an artifact. So I'm going to keep it all together as something that's well-versioned that I can use in the future. And then I want to release that. So what does a release look like? So there's still a good bit of code here. But as a release, it's very similar. So it's a job. I'm going to run it on Ubuntu. Here, I'm going to use the Terraform installer task. So I want to make sure I'm using the latest and greatest version of Terraform. .12.13 came out fairly recently. I want to make sure to use all the new syntax with .12. It's great. And then I want to use the Terraform task. And instead of doing a init, plan, and apply separately, something else that has been something that I've wanted for a long time that I added in here is a CLI command. So very similar to using the Azure CLI command within Azure DevOps, I want to drop into a pre-authenticated environment that I can run my scripts. So I want to be able to use Terraform, but I don't want, as a developer, to necessarily know where Terraform is going against, what it's, what the service connections are. I don't want to manage keys. I just want to write my code and make sure that it works. And so we've added support for being able to pull in a script and running the script, but if you notice, there's no init because it knows where it's going. And there's nothing here to say, how do I want to authenticate it? There's no keys, anything like that. I'm just running CLI commands pre-authenticated against the right environment for my pipeline. And I specify that through here, so I say, what folder do I want to be in? Some of these things like backend state file key. So when I mentioned Terraform keeps your state, keeping it in a storage account, it's just a file. So it's just a text file. If I've got 10 or 20 pipelines all going to the same storage account, I need to give it different file names. Oftentimes, for security purposes, we might use different storage accounts because they're cheap, and it's easy to keep separation. So with that, I put defaults to just terraform.tf state, but we've got a bunch of different demos using the same one, so I've got that separate. And then I can say, what service connection is it using to get to Azure? And actually, I have the opportunity to give it a couple different things. There's a few more things we've expanded on in this task to say, what if I want to deploy to an Azure storage account for all of my Terraform state files, but I might be doing a multi-cloud deployment. So I've got some provisioning that's happening in AWS and some provision that's happening in GCP also. But as an IT administrator, I want all my state files in the same place. And so it actually supports different front ends and back ends. And so I can keep my back end connection one place and my actual provider connection to go deploy resources totally separate. And so totally up to you how you'd want. But here I'm giving it the name of the storage account and the name of my service connection. And then I can just write Terraform. And so if I'm used to the CLI, if I'm real familiar with writing Terraform init, plan, apply locally, I just write the same thing. I don't have to do anything extra. And so in this case, I'm running Terraform plan, and I'm specifying, here's the variables that I want. So one of the things that I passed in, name and location have a bunch of defaults, but environment. I always pass in environment as a Terraform name, because to me, environment is really critical, because I want to have the same template work in dev staging and production. If I deploy the same app service with the same name in 2 different resource groups, the second one's going to fail, because its name is a DNS entry, and I need to have something unique. And so can I always pass that in? So I'm generating out a plan, I'm applying the plan, and then I mentioned this earlier, I want to do an app service deployment on top of this, but I need to know what the name of that app service is. And for me, I won't actually know until Terraform runs. And so I can leverage some of the features of Azure DevOps to help bridge that gap. And so I can actually grab from Terraform output, throw it into an environment variable, and then use this command here, which is really, really useful if you haven't seen it before. Azure Pipelines will look for certain output in the logs and actually respond to it. And so some of the things I can say is, hey, Azure Pipelines, I want you to set a variable that scopes beyond just this running template. So beyond just this iteration. I want you to go to the next task. I might even want you to be able to go that to the next job. And so I can actually set tasks or task variables that are of a much, much broader scope. And so here what I'm going to do is I'm going to set an Azure DevOps variable based on my app name. And so when the rest of my pipeline is running, I can actually know what the app name was that I was talking to. And so Terraform will go stand up my application, get the output, get the app name, and then I'm going to use that later. And so I've got the same task again here. So download, what this does is it's basically saying I want to pull down those binaries that I published in the first stage, because I'm going to get my DLLs, get them ready for deployment. I don't really care about pulling them down if I don't have my infrastructure yet, so I'll do that a little bit later. And then I'm going to run that same task, that same Azure RM web app deployment. So I'm just deploying a web app. But in this case, I'm using the same parameters for the subscription that's pulled in from Terraform. And then I'm using that app name that was set before. And so in one pipeline, I've got a stage to build, a stage to release. I do my Terraform init plan apply. I deploy my entire infrastructure. I deploy my entire application on top of it. But now this is in a template. And so if I go back to my main YAML file that orchestrates all this, I want to do this for staging in production. So I'm just doing it twice. And if I want to stand up an entire new environment with all of my infrastructure, all of my applications, all I have to do, copy, paste, and say QA. Now when I run this, I'm going to get an entire copy of my infrastructure pre-deployed for my QA team, roll out my applications to it, current version of it, all seamlessly as part of my pipeline. And so with this, it makes a really, really easy way to get everything from off the ground to fully deployed. That copy-paste, like I said, at my last company, took almost a month to actually go provision by hand. Now, granted, it was a lot more complicated than just a couple app services, but if you've got Kubernetes deployments, if you've got service fabric clusters, it's hard to pave down all of that kind of stuff. And so this becomes really, really powerful. And so if I jump back to Azure DevOps, I can actually go see this deploy. And so if I click on here, I can see the latest build. I've got 3 stages. That's my dev, staging, and production build. I can see the artifact that's produced. If I go into staging, I can watch all the logs for what it ran. It's running Terraform. It's running Terraform installer. What's the command that it run? I can actually see the plan from here, see everything that I would need, and then have it actually go deploy my application. And so just if I were to save and push, that's going to go now deploy an entirely new environment for me. And so that's really, really critical. And I mentioned that this is great for something like app services. It's not that hard to deploy. So it's kind of, my demo is sort of the low-hanging fruit. If I'm using something like Kubernetes, I can really start to take advantage of Terraform to say, I want to configure not just Azure, but there's actually a Kubernetes provider for Terraform. And so I can deploy my Kubernetes cluster, and before I put apps on it, I can use the Kubernetes provider to go create a service account for Helm and give it the right permissions it needs to deploy to the right namespace for the right amount of time. I can enable the dashboard account. I can make any changes that I would want. But then there's actually, if I'm using Helm as a package manager for Kubernetes, there's a Helm provider for Terraform. And so I can use the Helm provider against the same credentials that came from the Azure RM output, so I don't actually need to know what the keys were to my cluster, to use that service account that Terraform also provisioned to go deploy my applications to the cluster. And so I can do things like setting up ingress and making sure Nginx is installed and setting up Istio and all those kinds of things, all automatically through one set of scripts, using Terraform providers for each. And then when that's all done, I can drop my app on top of it. And so I can go 0 to a fully provisioned working cluster. You may even have AKS running in a VNet with an app gateway, with the WAF turned on, all this really complicated environment that would take many, many, many hours to stand up and deploy the whole thing in like 20 minutes. All fully automated. And so this becomes a really, really powerful way to put these two tools together. So I mentioned this is coming. Like I said, it's in preview right now. We've got a number of different people that are using it in testing. I'd expect within the next couple weeks this is going to be out in the marketplace. I'm just waiting for Chris to get back from Ecuador. If you are interested in checking it out, flip back to my slides. If I can get to my slides here. So today, I've got a form out, aka.ms/Terraform Pipelines preview. Just going to ask for basically your Azure DevOps organization name and some information about what you're using right now. Yeah, so if you'd like to see this, go ahead and fill this out. This is just going to submit a form to me, so sometime in the next couple days. I'm speaking the next 2 days, so give me a moment. But I'll get you added into the preview, and so you can get access to this. Basically, we're just going to share it with your organization. I'll shoot you out an email saying, hey, this has been shared with you. You can go enable it. This is kind of our early ring. I am CI/CD pushing my extension to this build. So as I'm making changes, please note that it's very much in preview. It'll be submitted to the marketplace within the next couple weeks. You'll see some marketing from HashiCorp. You'll see some marketing from Microsoft. We're also on board. All the Microsoft Learn content is going to get updated based on the new set of tasks. So finally, there's going to be one official way to work forward and start to do some of these things. This is my contact information. If you want to find me, I'm on Twitter, LinkedIn. I'll definitely be tweeting about this. Or I recently found out that this was open, so aka.ms is our URL shortener. My name's Joey. You can go to aka.ms/Joey, and it'll link to my Twitter. HashiCorp is here. HashiCorp has a booth here. There's HashiCorp people in the room, standing outside. I will answer all of your questions. I'd love to take some questions here, but I know that it's already 9:45. There's some other people starting to come up. So booth 2013, if you want to follow me over, it's just that way a little bit, so just around the corner. I'm going to be there for probably the next hour or so, and there's a lot of people here, so I can answer lots of questions about Terraform and pipelines or Terraform, but really they're the people to go see. So if you're interested in Terraform Cloud, Terraform Enterprise, Vault, any of their other products, that's a really, really great place to go. But thank you all for coming. I hope that you're excited about this as I am. I think that this makes a huge difference, and have a great Ignite. Thanks.